Hi all. So this is the last topic, that is pumping lemma. Okay, so still now we have been proving that how to do the conversions of regular language, regular grammar, and we have know what is DFA, NFA, but it is entirely different from these concepts. But it has those concepts included. But there we have just proved, or we have keep on solving the problems of regular languages. But now we are going to do in opposite way. That is, we are going to say the particular string is not a regular language. Okay, so this pumping lemma is helps you to solve, or helps you to say that, or prove that your regular language is not a sorry, the language that is generated is not a regular language. Okay, so there are many ways to prove, but pumping lemma is very easy because it has some steps to be followed in order to prove a particular language is not a regular language. Okay, so our aim is to prove a particular language is not a regular language by using pumping lemma. Okay, then and then there are usually in regular language we would have seen many things like um, uh, the regular language 1 and regular language 2, if we union together, then it will give you a regular language. So these things we saw usually, right? So likewise we have seen that if the length of two regular language is less than the pumping lemma, the length, then you can say that it is a regular language. And if the length of y is equal greater than or equal to 1, then you can say it is a regular language. And if the value of x, y, k, so we'll see this one by one, but I'm telling you, by saying these by solving these three things, we can say that this is our language is a regular language. But we are going to do it in a contradiction way. That is, we are going to say this is not cannot be proved. That is, your length of xy will not be less than equal to p. Okay, length of xy will not be lesser than equal to p, then sorry, lesser than p, and then the length of y will not be greater than or equal to 1. And we are also going to see xy power k is not equal to, is not equal to 0. Okay, or it's not in the regular language. So by proving that, we are okay, usually generally we prove these things for to say that a language is a regular language. But we are going to solve it in a contradiction way by saying that these conditions are not satisfied. By not satisfying the condition, we are saying this is not a regular language. So this is the pumping lemma way solve a to solve prove that the regular language is not a so the language given is not a regular language. Okay, so it gives a method of for pumping, generating many substrings. Okay, pumping is nothing but a pump generating substrings. Okay, in other words, we say it by breaking a given long input string into several substrings. Okay, so a particular, for example, if for a language is given, okay, a power n, b power n. Okay, a power n, b power n is the language given. We will be creating strings for this language. You know how to create the strings. So if n is equal to 2, okay, then the strings generated will be s is equal to a b b. Okay, so number of a's will be a power 2 and b power 2, means now 2a and 2b is given. So this is the string given. So we'll generate the string for the given language, and we'll create for the particular string, we'll divide the string into x, y, z. Okay, so from the language I have created string called AABB, and I'll divide the string into three terms. That is, I can take anyway x, this AA belongs to x, and B alone belongs to y, and this Z alone belongs to B. Okay, so the B alone belongs to Z. So x is equal to AA, y is equal to b, and z is equal to b. So then I'll apply and I'll check these condition for these given separation. Okay, I'll create a string. From the string, I'll separate the strings into x, y, z format, and from that I'll check these conditions. If the condition is satisfied, it's a regular language. But if the condition is not satisfied, then that will not come under the regular language. Okay, so that is what our aim is to. Okay, so till now we were solving regular language and regular expressions. Now we are in the other way to prove that it is not a regular language. Okay, so why we are going for this? Because some language will be accepted by the machine, some language will not be accepted by the machine. So to check whether this language is accepted by the machine or not, we use pumping lemma. So whenever a string enters into the machine, we use pumping lemma to check whether the string is accepted or not. If and only if it accepted, it will be entering into the machine for the process. Okay, so it's a checkpoint to find whether the string is accepted, it's a regular language or not. Okay, so we'll solve it with an example. And one more thing, we have a one minute. So we have this rules also for pumping lemma. Okay, so we'll solve. I'll have this rules in the whiteboard also. I'll show it. Okay, so that you'll understand it very clearly. Okay. Fine. So these are the rules. Okay. So the pumping lemma is to say that the language is not a regular language. Okay. The language created is not a regular language. Okay. Not a regular language. Okay. So these are the steps to be followed. Okay. So first step is have to assume that L is a regular. Okay. So I'll take an example to solve it step by step. Okay. So the example is A is equal to A of n, B of n. Okay, n is greater than equal to 0. So this is the language given. Okay, so A is equal to A of n, B of n. By theoretically, if you see this, I hope I would have told this in the first class of a regular expression or regular language. Okay, here it is A of n and B of n. Okay, so if suppose n is equal to 2, A will be done twice and B will be done twice, right? So if the value of A is A power A square, then A comes 2 times and B. Similarly, if n is equal to 3, 3 A's followed by 3 B's, right? So here the contradiction, the main thing is A should be first, the string should generate A, the machine should generate A by, because n value is same for both A and B. Yes, so it is not A power n and B power m. It is A power n and B power n. Since the value of both the n's will be same, so the machine has to remember the number of A's, then only number of B's will be generated. So since we are in the topic of finite state machine, it has no memory. So since it has no memory, it cannot remember how many times A comes. For example, it is 2, it is 20, 20, 20 na. The machine has to remember the A came for 20 times. This machine is not, doesn't have any memory power. That is, it has no brain. So to store the information, how many times the A came. So because of that, we cannot use this string. This string will not be accepted, or this automata, this language will not be accepted by finite state machine theoretically, but we have to prove by using pumping lemma. We know by seeing that it has some storage, so it cannot be accepted by finite state machine. We'll come to a conclusion, but we have to prove that. So for that proof, we have to use pumping lemma methodology. Okay, so I'll tell you through steps how to solve this problem. Okay, so we'll start from step 1. Okay, so the step 1 is 1 minute. Okay. Okay, A power n. This is the language given. Okay, so now we have to, first step is we have to assume L is regular. Okay, so here it is A, so I'm saying A is regular. Okay, I'm just assuming it is a regular language. First, we know it is not regular, but we are assuming it is regular. So the pumping lemma should hold for L. That is, you have to find the length of pumping lemma. Length. Okay, now we have to find the length of. Okay, so now we have to find the length of P, length P. Okay, that is pumping length. Okay, so pumping length is P. Okay, so this language is okay here. Okay, so I'll go in this flow itself. Okay, so L is regular. So pumping lemma should hold L. So length, now we have to give some pumping length to this language. Okay, assume that this pumping length is, and we have to create a string. Okay, so first is I have accepted this as a regular language. Then I told that it has some pumping length, and it has to, the pumping length is P, and all the strings longer than the P can be. Okay, so now I have to generate P. Yes, okay. So this is the step. Don't confuse by seeing the steps. Okay, now I am creating a string for this particular language. Okay, for example, if pumping length P is equal to 7. Okay, so I'll put So it is a power 7 and b power 7. So the string generated will be a 7 times a and 7 times b. Okay, I hope you are getting. So first I have taken the language and I'm assuming that it is a regular. Then I'm creating a pumping length, that is 7. Then for that 7 I have generated a string for this particular language. Okay, so this is first step, this is second step, this is third step and fourth step. Okay, now we have done for 4 steps. Now I have to say that now we have done 6 step also, for 5 steps. Now sixth step is divide this string into xyz. Now this string s is divided into xyz. I can say any way. Okay, that is I can separate it in any way. I can go either this 3 strings in a, sorry, x, and this, okay, this will be in my y, or this I can go as z, or I can also say this 2 will be x, this a's are in y, and all b's in z. Anyways I can separate the string. So now I'm separating in this way. Okay, so I'm separating this way. So number of x is equal to, so x is equal to a, y is equal to a b, and z is equal to b b, b b, and b b. Okay, so now I can go y x in full a terms and y in one b and z. Anyways you can separate. Now I'm separating in this way. Okay, I have separated it. Now I have to show these 3 conditions that I have told now. X y power I is z is not in regular, is not accepted. Then you have to prove that length of xy is greater than or equal to 0. Yes, and also you have to prove length of y is great x of sorry, the length of x and y is lesser than p, and you have to prove y is greater than 0. Okay, we are proving in the, this, if it is not a regular language, this conditions will not be accepted. If it is a regular language, this conditions will be accepted. So I'm taking the first condition, that is I'm going to make this as x y I z. Okay, now I'm giving the value of I is equal to 2, for example. Okay, so x will be a for the string generated for pumping length 7. Then y power I, y power 2 is you have to create 2 times of a, 1 2 3 4 5, and again 1 2 3 4 and 5. So 2 times a, so I have written 1 time b, and sorry, 1 time y and another time y, and this is x, and again z terms are 6b's. Okay, so now I have created in such a way that x y power I is y and z are generated. Okay, from this you can say that it is not actually a power n and b power n, because it should be in the form of a b b, or a 7 times b 7 times, or a infinite times b infinite times. But if you see here, this is not following the same form, because one b comes in between and another followed by some set of a's and one b and all set of b. So now by seeing itself you can say it is not in the form of a power n and b power n. You can directly say that it's not a regular language. Okay, if you have created from the language given in the question, you have given the pumping length, and based on the pumping length you have generated the string. You have, from the generated string, you have divided into x y z terms, and you're applying in the first condition of regular language proof. Okay, so x y I is applied. See, but when you apply the given string in this form, you got the string which is not a regular language. Okay, that when the regular language given is a power n b power n, but it is not in that form. So this is not a regular language. Okay, similarly y should be, the length of y should be greater than 0. What is y? Yes, this is in this condition, this is y is greater than 0, but x and y should be lesser than equal to p. The pumping length is 7 here. Okay, x and y, number of x is equal to 1 2 3 4 5 6 7. Okay, number of x is equal to 3, and number of y is equal to 1 2 3 4 5. Okay, so 5 plus so number of x and y is not even equal, and it is not lesser than or equal to p. Okay, so because 3 plus 5 is equal to 8, so 8 is not lesser than equal to 7. So this also proves that it is not a regular language. Okay, so to prove it's a regular language, you have to satisfy these conditions. Okay, if this condition is not satisfied, then the regular that language generated is not a regular language. Okay, so this is what a pumping lemma is. Okay, so okay, so again I'll take one more example to help you to understand better. Okay, the next example that I have taken is a is equal to y, okay, and y belongs to 0 comma 1 whole epsilon. Okay, you have to prove this language is not regular. Okay, so we also know, see here you can say, so this y has the now input as 0 0, so the strings will be in the form of 0 1 0 1. Similarly, if the value of if it is 2 times, then it will be 0 1 0 1, and some way, so it is whole star na, you can also say that it will be in this format. Okay, so this is how your strings will be, the combination of strings will be in this form. Okay, now by the step 1, I'm saying this as my a of y is regular. Okay, regular. Okay, next we are saying it is now we have to prove it theoretically. Okay, so the proof will be so now I have to generate string first. Okay, first the pumping length will be again the same way. Okay, now I said this is a regular, then I'm giving it pumping length as 7, and s will be, okay, s will be, I can take anyway 0 1 and okay, it's my choice of giving in this way. String will be in this combination. I can also go in this way also, 0 1 p and 0 1 p. Okay, anyways you are going to prove it is not a regular language, that's all. Okay, so now I have given pumping length as 7. I can solve any way to say that it's not a regular language. So I'll take this format, this string format, and I'm saying it. Okay, now I'll generate by the value of pumping length, I'm generating the string. Okay, the string will be 0 0 0 0 0 0 0 and 1, and 7 zeros and 1. Okay, so now I have generated the string. Okay, 7 zeros followed by 1, because 0 power 7 7 zeros 1, and 0 power 7 7 zeros and 1. Okay, now I have generated the string. Now my aim is to divide the value of x and y, right? So now I'll take this two terms as x, and these I can go till 1. Okay, these terms as y, and I can separate this as z. Okay, I can also go anyway. So now value of x is equal to 0 0, y is equal to 0 0 0 0 0 1, z is equal to 7 zeros followed by 1. Okay, now what you have to do is, now you have to prove that it is not a regular language. So first we will take x y I z format. Okay, to prove that it's not a regular. Okay, now I'll give the value of I is equal to 2, for example. Okay, so x is equal to 0 0. Okay, so y is I, so I have to put twice, 0 0 0 0 0 1, again 0 0 triple 0 1, and z is 7 1 2 3 4 5 6 7 zeros and 1. So this is the string generated by when you use this string and is2. Okay, when you see this here, it should be in the form of 0 1 0 1 or 0 0 1 0 1 0 1. Likewise, you have to your string should be in the form of this. Here itself the string generated is not correct, right? Because see here, if it has 7 zeros, okay, for example 1 2 3 4 5 6 7, before 1 if there are 7 zeros, after 1 also there should be 7 zeros, but here then you count it is not 7 zeros, in between you have some other different type of string, but here at the end you got 7 zeros followed by 1, but in between that particular rule is not followed, the particular format is not followed. But if it is a regular language, this rule will be, this particular string that will be followed. But now it shows that it's not a regular language. Okay, similarly the length of y should be greater than 0. Yes, it is 0, but length of x and y should be lesser than or equal to p. See, consider this length of x 1 2, length of y 3 4 5 6 7 8. Okay, or you can also say this way. Okay, so these terms are x terms and these are the x and y terms, right? So these are 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So there are 14 combinations of x and y, and the length is not equal to the pumping lemma length. So this is also proof that it's not a regular language. Okay, so by solving it in the other way, we can say these languages are not regular, and this through pumping lemma, through pumping length only, we are finding whether the language is regular or not. Okay, so now you would have understood how to prove that your language is not regular by using pumping lemma.